Today we are going to learn about the future space missions of India. So in this, let us look into the future space missions. So many Earth observatory satellites, that is new launch vehicles, crew vehicles, space stations and probes are lined up. Now let's look into the one of the satellite, that is 𝗬𝗏𝗧-3. 𝗳-SAT-20 for communication by 𝗂𝗽𝗱𝗁𝗃3 and 𝗂𝗽𝗱sat-1 for Earth observation it would be launched by 𝗂𝗽𝗱-2. And 𝗬𝒑r, there is another satellite, that is a spectral imaging. In collaboration with NASA, we are going to launch this satellite. And 𝗂𝗦𝗃-2, that is an advanced hyper spectral imaging. These are the satellites that are going to be launched by ISRO. Now let's look into another interesting thing is Gaganyaan. Gaganyaan is an India's indigenous space mission to take humans into space by 2022. It was initiated in 2018. So what is the significance of this sending humans into the space? The background of the space is that the colonization and space as a great force in the future. There might be a colonization of this space by humans, and this space can become a sort of great force for us. In the US, we all know that in the US, the private companies like SpaceX by Elon Musk pursuing to colonize this Mars itself. So in 2004, human space flight program initiated there. So in India also, we are also having a Gaganyaan as a mission to send humans into the space. It was finalized in 2007. Prime Minister announced the mission on August 15, 2018 in his Independence Day speech. Now let's look into this details of this program mission. It is a joint venture of a Department of Space, that is ISRO, DRDO and HAL, that is Hindustan Aeronautics Limited. So this is a joint venture of these three departments. So what DRDO would do here is, DRDO would supply space grade food, crew healthcare and fire suppression system, emergency exit, etc. Here, when a human being enters into the space, he will be staying there for a long time. Even for a long time means he has to take food. That food is requires, and a special food is required. You know, when you take food there, waste disposal that is produced by the humans also a big problem. So in order to avoid, in order to minimize these things, the space grade food is manufactured specially. So and crew healthcare is also very important. When you go to the space, the entire atmosphere changes there. You know, human body will have a specific temperature, a specific pressure. All these things are required in the space also. So when you go into the space, you will be actually working under a microgravity, or the gravity is very less. So there human body behaves differently. In order to take care of that human health, the crew health is also taken care. In order to do that, the DRDO would supply this crew healthcare related issues, will do research and will do solutions to take care of the crew health there. And again, the fire suppression systems. You know, when a satellite is sent into the space, the satellites would go at a higher speed, at a speed that would actually create around 3000 degrees centigrade temperature. And then if anything happens in that satellite, in that mission, that crew, where the crew stays, so there is a higher chance that the fire will can come at any time. In order to suppress this fire, we need to have a special systems that would suppress this fire. So this fire suppression system is also supplied by DRDO, and there is an emergency exit emergency exit is a very, very important part in any missions. You know, we are talking with the human lives. If even a small mistake would actually cost the human lives. So in the event of that emergency situations, we should have the emergency exit solutions. Further, the DRDO is coming up with the emergency exit solutions. So apart from this, HAL is also contributing for the crew modules. We all know that HAL is actually into the fighter jets and aeroplanes like that. Since this is it is into the aeroplanes and manufacturing aeroplanes or fighter jets, we all know that LCA is manufactured by HAL. So in order to, since using this expertise, the HAL is actually designing these crew modules. Crew modules means the crew that would actually stay in that particular modules. So for that, this HAL is since it's using his past experience in designing the LCAs and other various military grade fighter jets. So this expertise will help them in designing the crew modules. So the mission will be launched in 3 stages. That is unmanned launch in December 2020, unmanned launch in July 2021, and then unmanned launch in December 2021. Now let's look into this. And in pursuit of this, ISRO has been testing technologies like space capsule recovery equipment and crew atmospheric re-entry experiment, and then a reusable launch vehicle technology demonstration, that is also called RLVTD. So GSLV, MK3 and so on, these are the things. Now let's look into the space capsule recovery equipment. You know that when a space vehicle takes a crew into the space, then we have to take that back also. So we have to take that back also means we should have that capsule recovery equipment, which is actually recovers the equipment from the space capsule that we are sending. So apart from this, when the crew enters into the atmosphere, it requires a special re-entry experiment is required for this. Special modules are required when a space station, when a satellite re-enters into the atmosphere, it actually comes with a huge velocity, with a high velocity. When any satellite or any object comes at a speed of high speed, you can imagine even a free fall will have a 9.8 meters per second, and it actually comes with the space satellite that is entering into the Earth will actually comes at a very, very high speed. When this comes with a high speed, we need to take care of the crew that is there in that satellite. So for this they are providing this care module technologies, and there is another reusable launch vehicle also required. When you take a launch vehicle, we have extensively discussed about the launch vehicles. When the launch vehicles takes the satellite into the space and then it has to take that back also. So that means we need to have a reusable launch vehicle also. So in order to have this reusable launch vehicle, we need to have this technology demonstration. So GSLV MK3 is also one where we will be using, because GSLV MK3 is nothing but cryogenic engine that we are using there. In January 2019, Human Space Flight Center, that is was inaugurated within this ISRO headquarters. So Dr. Unnikrishnan Nair is the founder director of this Human Space Flight Center, and V.R. Lalitambika, who spearheaded this PSLV-C3, is the mission director for this Human Space Flight Center. In January 2020, ISRO unveiled humanoid robot 𝗹𝗻𝗃 to assist the 𝗹monauts for ambient settings and orbital period. So 𝗹monauts is nothing but the people who enter into the space are called 𝗹monauts in Indian word. So when a human goes into the space requires a special, I've been discussing about this, that the humans required a specific ambience, a specific atmospheric pressure, specific environment is required. So for that, a humanoid robot will help assist these 𝗹monauts for setting up this ambience and also during this orbital period. The cost estimated for this mission is 10,000 crores. The mission seeks to transport 3 Indian 𝗹monauts to low Earth orbit of around 300 to 400 kilometers for 5 to 7 days, which means 3 Indians will actually go into the space at an altitude orbit of 300 to 400 kilometers from the Earth, and they will stay there for 5 to 7 days. And after that, there would be a return flight of 36 minutes to Bay of Bengal. You see, in 36 minutes, the people, those 𝗹monauts would come to the Earth from 300 to 400 kilometers. So with this, India would become the 4th country to achieve this feat along with USA, USSR and China. So the mission is collaborated with Indian Air Force and the Institute Aerospace Medicine. 4 pilots of this IAF being trained in Gagarin Research and Test Cosmonaut Training Center in Russia. So India is developing own astronaut training center at Challakere, Chitradurg district for next 3 years. Do you know who was the first man in space? That is Yuri Gagarin. Of course, Indian is Rakesh Sharma is the first Indian to be in that. This 1984 as part of this intercosmos through Soyuz T11 he went there. And Yang Loi, October 2003, he is a Chinese. He was the first Chinese to enter into the space. So what are the major challenges to send the humans into the space? The human conditions for space travel in microgravity and huge radiation. So we all know that the sun actually, radiates a huge radiation into the Earth. The atmosphere actually filters this radiation and sends that radiation which will actually conducive for humans to live on the Earth. Well, since you are going out of this Earth's atmosphere, so this humans, whoever goes there, will actually face a huge radiation. The human actually is not meant for facing this kind of radiation. In order to face this, especially artificial, this different radiation conditions, and the human needs to train that. So for that, human have to maintain a conditions in the module that would be as it is on the Earth to the maximum extent. As we all know that there won't be any gravity or very microgravity, very less gravity is there. There the Earth conditions would be different. So in order to sustain that, human conditions have to be, that module have to be prepared so that the human will have the least differences in that. So for that, we need to have this special create the special conditions, and we have to create that design those modules in such a way that we'll have a very less differences between what is there in the on the Earth and what is there in the space. And then apart from that, humans have to have a special training and fineness. So any simple mistake can cause entire the mission failure and the death of these astronauts. See, there's a 0 mistake is what we need to achieve there. because for that you need to have a special rigorous training is required for this. And then we need to have the escape strategy and paired abort tests. See, if you want to enter into the space, you need to achieve that escape strategy also. So when you escape the Earth's atmosphere, you need to come to that Earth again. For that, you need to have a different strategy and then paired abort test that you have to conduct. So these are the main challenges that you need. Apart from this, we need to see that the investment and modular costs. So every modules that we cost, every investment that we make, the government should also keep that investment ready so that they will design these things on time. Apart from this, we do have collaboration with foreign space agencies. The United States, USSR, that is Russia, they went to the space, that taken these humans into the space. Their expertise will certainly going to help us so that we can avoid any mission failures. So for that, we need to collaborate with them, and collaborating with the foreign space agencies is another challenge because it actually requires the transfer of dual technologies, which is, we call this dual technologies, means the technology that is used for peaceful civilian purposes as well as the technology that is used for military purposes. So not every country would ready to collaborate with India for that. So we need to have a collaboration with the foreign space agencies, and that also another challenge. And apart from that, there is another diversion of this 10,000 crore from mainstream economy. So we all know that the India, when the budget is allocated, and they might be diverted for other purposes also. So this is another challenge that we need to overcome. So what is the significance of this Gaganyaan? The manned mission in microgravity will have this widespread applications in health, animal sciences, biotechnology, material science, defense, etc. So we all know that many technologies were results of the space research, like telemedicine, that is robotic surgeries, are actually the results of this space missions, manned missions. The advances in laser surgery, water purification, etc. are also the spin-off technologies of this research that is done in order to send this man into the space. So we all know this biotechnology, material science, we need special materials to send the spacecraft, the satellite into the orbit. For that, we need a special material. In doing this research, we have found out different materials for that. The same material that we are using for this defense also. So all these things are very important spin-off technologies. Apart from this augment actually a science and technology development of country, as 60% of the sourced from private sector itself. For example, the microgravity platform can be experimented for new technologies. For new technologies, like we all know that there is one in Hyderabad itself, there is a zero gravity is there, where you will actually experience that free fall in this. That is actually taken from the Russian technology. It is actually a entertainment purpose. They have established in Hyderabad itself, where we can experience this microgravity here itself. And apart from that, we all know that the economic activities like employment, HRD, human resource development, industrial capabilities would be benefited, as this most of the people are engaged in the research and development of this. They will also get employment. There is also human resource development would take. Apart from this, the social benefits will actually get that spin-off technologies. This technology, while doing this technology, we also have a spin-off technologies that are helpful in agriculture, health, etc. So communication, even safety and waste management, these are all most of the technologies. While developing doing this research, we have developed a lot of technologies. All these technologies are used in this agriculture, space, communication, safety, waste management, etc. Apart from this, we also have the national pride and institutional growth as multiple agencies like ISRO, academic, industry and national agencies are involved in this, but actually give that national pride. So isn't it a great thing to achieve? It's only the 4th country in the world on the globe to send a human into the space. It's obviously a great pride for us. Further, the Gaganyaan would put India on global map of space diplomacy and international collaboration, apart from inspiring the next generation. So who knows, the Elon Musk, another next generation Elon Musk might come from India itself. The space science and exploration, now let's look into this another future missions. India's space program encompasses the research in areas like astronomy, astrophysics, planetary and earth sciences, so atmospheric sciences and theoretical physics. So we have sent balloons, sounding rockets and space platforms and ground-based facilities support these research efforts. So a series of sounding rockets are available for atmospheric experiments. The several scientific instruments have been flown on satellite, especially to direct a celestial X-ray and gamma ray bursts. So one of that is AstroSAT. AstroSAT is the first dedicated Indian astronomy mission aimed at studying the celestial sources in X-ray, optical and UV spectral bands simultaneously. The payloads covered the energy bands of this ultraviolet ray, that is near Earth, as well as far ultraviolet rays, a limited optical and X-ray regime, that is 0.3 kilo-electron-volt to 100 kilo-electron-volts. So we all know that the sun emits a radiation, and that radiation consists of various radiation, that is a UV radiation, X-rays, all these kinds of radiation that what we see this radiation is only a part of the sun, that radiation that sun emits. Apart from this visible light, the sun also emits these X-rays, UV spectrons, all these things. So in order to study the nature of the sun, we will actually study the light that is radiated from this sun. So this radiated light that actually is in the form of X-rays, in the form of optical and other UV spectral bands. So if you study these things, we can actually study the sun's nature and the sun's behavior also. So this AstroSAT with a liftoff mass of 1550 kg was launched on September 28, 2015 into a 650 kilometer orbit, as inclined at an angle of 6 degrees to the equator by PSLV C30 from the Satish Dhawan Space Center, Sriharikota. The minimum useful life of this AstroSAT mission is expected to be 5 years. That is the minimum thing. So apart from this, there is another important mission, that is Mangalyaan 2. So Mangalyaan 2, it would be a future only orbiter, no lander rover mission, and where we will be sending this satellite to revolve around the moon and then around the Mars. This Chandrayaan 3 is another, most probably it would be include the lander and the rover along with orbiter. The moon mission is necessary for resources, water and space colonization. As also the moon can be a good station for future space exploration. So we all know that Elon Musk is trying to send people onto the moon, in the next 50 years, 100 years, we might go into the moon, like we'll go to the another, Ooty, Goa, like that. We might go into the moon also. So if you want to do that, if you want to colonize the space there, we should also have the technology to send the people, to send the satellites onto the moon also. So if we want to do that, we need to check that, there might be resources that are there on the moon can also be help us for the future. So we all know that rare earth metals are very important in the semiconductor industry, which are very rare earth metals. So we might find the rare earth metals on the moon, and if you find the rare earth metals on the moon, there might be some sort of a transportation, extracting the rare earth metals on the moon and then bringing that back to the earth. So this kind of things also might happen in the next 50 to 100 years, maybe in 10 or 50 years or 10 or 15 years also. We don't know what. So further, to make ourselves ready, we should also do these experiments. That's why we are doing this Chandrayaan-3 kind of experiments. And there is another important thing that is Shukran. Shukran is another, due to similarity in size, density, composition and gravity, the Venus is described as Earth's twin sister. Some theories suggest that the both planets share a common origin. However, the Venus has a much higher solar radiation. The purpose of this Shukran would be to explore the effects of solar flares and study the atmosphere of the Venus. We all know that primarily the atmosphere of the Venus is made up of carbon dioxide. The ISRO intends to send an orbiter mission only with this Shukran. And there is another important thing, AstroSAT. It is a follow-up to AstroSAT mission. It will actually further explore the bright X-rays sources in the universe. So it will actually also observe the neutron stars, supernova and region around the black hole, etc. So this actually takes the various light that comes out from these supernova and the black holes and then neutron stars, and then they study that, so that it will help us understand these black holes, it would understand the supernova, it would help us understand these neutron stars. Now let's look into the launch vehicles. We all know that small satellite launch vehicles, that is a 500 kg small missions, which has 4 stages, a 3 solid and 1 velocity trimmer, and then we also have reusable launch vehicle technology demonstration, and then there is another unified launch vehicle that with the modular architecture to replace PSLV and GSLV MK2 and MK3 with a single line of Victor engine. So Victor engine is the engine that we are going to develop for this. And there is another launch vehicle, that is super heavy launch vehicles, which would be around 50 to 60 ton launch vehicles, where it can take 50 to 60 tons of payload. So what are the feature launchers of India? That is RLV-TD, that is a technology demonstration, we'll call TD. The reusable launch vehicle technology demonstration is one of the most technologically challenging endeavors of ISRO towards developing these essential technologies for a fully reusable launch vehicle to enable low-cost access to space. So we all know that if you want to send humans into the Earth, we should have the reusable launch vehicles also. Reusable launch vehicles will actually lower the cost also. So in order to, if we can do this, obviously reusable launch vehicle means sending a launch vehicle into the space and bringing that back will actually solve the major problem of sending humans and then bringing them back is the major problem that we are going to face. And if we can solve this, obviously we can solve many problems related to this, sending the humans into the space also. So this RSLV-TD consists of a fuselage, that is a body, a nose cap. A nose cap is the one that's on the, it's like a nose, and then double delta wings and a twin of vertical tails. So as it is shown here in this, it also features symmetrically placed active control surfaces called ailerons and rudders. So these are active control surfaces. So this is what looks like RSLV-TD. The selection of materials like special alloys, composites and insulation materials for developing this RSLV-TD, and the crafting of its part is very complex and demands a high skilled manpower. The objectives of this RSLV-TD is hypersonic aero-thermodynamic characterization of wing body, evaluation of autonomous navigation, guidance and control schemes, this integrated flight management, a thermal protection system evaluation. So these are the important things that we will achieve. So what are the achievements for this? The RSLV-TD was successfully flight tested on May 23, 2016 from Satish Dhawan Space Center, Shriyarikoda, validating the critical technologies such as autonomous navigation, guidance and control, a reusable thermal protection system, and re-entry mission management. And there is another important thing, that is a space debris. Space debris encompasses both natural and artificial particles. The meteorites are in orbit about the Sun, while most artificial debris is in orbit about the Earth. The term Kessler syndrome is associated with space debris, which is used to describe a self-sustaining cascading collision of the space debris in LEO, that is low Earth orbit. The obstruction to various space endeavors are due to this debris. The NASA estimates that there are about 5 lakh species of debris larger than ½ inch across in low Earth orbit, posing a potential danger to the 780 odd satellites operating in the area. So debris is bound to increase because we are sending a space scientist concern is about this, because we are sending inexpensive tiny satellites called CubeSats, which are going to add space junk around 15% in the next 20 years. The initiative taken toward the space debris cleanup, as there is no international treaty on space debris currently. To remove this debris, satellite platform will showcase 4 methods for release, capture and debris to space debris targets called 𝗹𝗶𝗇. The net capture, it involves a net that will be deployed at the target CubeSats, and there is another harpoon capture which will be launched at a target plate made of a representative satellite panel materials. And there is another important vision-based navigation using the cameras and LiDAR, that is light detection and ranging. The platform will send data about the debris back to the ground for processing, and then the deorbiting the process. As it enters the Earth's atmosphere, the spacecraft will burn up, leaving no debris behind. The mission will demonstrate key active debris removal, that is area technologies in orbit, which will have significance for future missions as well. So what are the India's efforts for this? Mission Shakti, which was launched recently, was done in low orbit of less than 300 kilometers at a particular angle to ensure that thus minimal debris were dispersed above into the space to avoid this damage to other satellites of the International Space Centers. The team of ISRO and Physical Research Laboratory are working on setting up an observatory to track the space junk. A multi-object tracking radar developed by this Satish Dhawan Space Center allows ISRO to track 10 objects simultaneously. So it tracks India's space assets and space debris, for which India was solely dependent on the data provided by the US Space Agency NASA till early 2016. So thank you very much.